So we're told that the triangle is isosceles. That means two sides are the same. We'll call these two the same sides. Okay. The two congruent sides are 12 inches. So this is 12 and this is 12. And then the side that they haven't labeled is 8. Okay. So we're supposed to find the angle that a side of 12 inches makes with the 8-inch side. So here's a side of 12 inches. Here's the 8 side. So we'll call this the angle x or theta, whichever one you want to use. That's what we're supposed to solve for. It's not a right triangle though. So we don't know which one the hypotenuse is. We can't use SOHCAHTOA. We can't use any of those. But you can break it up to a right triangle by drawing a vertical line right down here. If it's truly isosceles, then a line that makes a right angle with this side length down here splits it into half so that this is 4 and so that this is 4. And now we have something that can help us. We know this side length, which is adjacent to theta, right? And then this side length is the hypotenuse because that's the one across from the right angle. So now we can use cosine to help us solve. Need a little more room. Cosine of theta equals the adjacent side divided by the hypotenuse side. And so to get theta by itself, they didn't say whether it's radians or degrees, so we'll just go with degrees. To get theta by itself, though, we got to break out that cosine. So we're going to use cosine in the negative first to both sides. So cosine, sorry, I said that wrong. It looks like cosine in the negative first, but it's inverse cosine to both sides. I did what most students do. Okay, so we need we need inverse cosine of 4/12. So I'm going to do 4 divided by 12 in my calculator. And on a Windows computer, you have to hit Trig, second cosine. So there it is in radians, but I said I was going to do degrees. So let's do that again. 4 divided by 12. Oh, it switches that. Then hit second. So to get inverse cosine. So I got 70.5 degrees. I think that's it.